Okay, we're on quiz number 12, and comes from chapter 7. So, what quantum number describes the orientation of an orbital in space? Remember, you have those 4 quantum numbers. Which one describes the orientation? The orientation would be the M, just the M, and the M being magnetic quantum, so M number. What quantum number describes the shell in which the electron is located? The shell always is the N number, and that's a pretty important number. That would be the principal number. Principal quantum numbers would be the N number, the principal number. Which of the following states that no 2 electrons in an atom have the same 4 quantum numbers? So the reason they don't, and that's why you can't have, when you get down to the spin, you have usually a positive spin and a negative spin, because you can't have, the same electrons can't have the same 4 numbers. So that's called the Pauli exclusion principle. It means that they can't have all 4 quantum numbers. Which of the following states that a single electron occupies each orbital within a subshell before electrons begin pairing? The key word is pairing. Anything to do with pairing is the Hund's rule, right? If it's a single electron, it will actually be used up before pairs will begin pairing. So that's Hund's rule. It has to do with pairing. So whenever you see that word, it's going to be Hund's rule. Which of the following specifies the order in which subshells fill with electrons? This word, Aufbau, A-U-F-B-A-U, principle, that means building up. I think it's in German, building up. Well, building up means the order the shells are built up, so which of the following is the order of shells building up? That's building up. That's the Aufbau principle, means building up. What type of orbital has a spherical shape? S. S orbital is spherical. The P is like dumbbells. D is like a cross. They get more complicated. But S is spherical. The second shell from the center of an atom can hold up to 8 electrons, okay? Arsenic has, and the first shell always holds 2. So arsenic has the Lewis symbol like this, and how many electrons are in the arsenic's outermost shell? 1, 2, 3, 4, 5. 5. It's 5 dots, because this tells how many are in the outermost shell. The complete arrangement of electrons in an atom is what? The electron configuration. So just remember, electron configuration, which is what we're talking about this whole chapter, is the arrangement of electrons, how they're arranged. The outermost electrons in an atom, which are involved in chemical reactions, they're called the valence. Very important, because that's how chemicals react, because of their electrons and their valence electrons. Those are their electrons that they can get rid of, or they can give, or they can take electrons, and that's the valence. Okay, and the other from chapter 7, and this is the last from chapter 7, and this is quiz H. It says, give the term for a column of elements. The columns, they're arranged in columns. You got these columns, right? Columns down of the periodic table. They're called groups. Give the term for a row of elements. The row means across, means these rows across. There are period, right? Period. On which side of the periodic table are the metals? The metals are the left side or the right side? They're going to be on the left side of it. Metals on the left, non-metals on the right. True or false? Most common chemical reactions involve main group elements. Yep, that's true. What are elements of group 18? Group 18 is this last group here, clear at the end. Group 18. And these are called noble gases, because they don't really like to react, because they have full electrons and they don't need to take or give any electrons, so they're very hard to react. They're called noble gases. That'd be a test question, I'm sure. So let's see. Let's go. Okay, let's go on to quiz 13. I'll do your quizzes, and then we'll do go over the test in a different video. So here we have quiz 13. Can you see it here? So hopefully, how come it's blurry? here we go. I don't want you to have it blurry there, okay? So how many electrons are in the 2p subshell of the nitrogen atom? So the nitrogen atom, as you look in your book, you'll find valence. The valence of nitrogen is actually a 3 valence. That means 3, so it will have, if the valence is -3, then it's going to have 3 inside that. So anyway, which of the following is the correct electron configuration from bromine? And bromine is in a halogen. It's in column 17. So halogens have halogens have 7 minus 2. So I have 7 minus 2. So they have 5. So which one would be the one with the 5 at the end? So for one thing, bromine has argon first. Basically, they just take argon, and it has argon's formula, and then they add this formula here. But I always look at the last one. If it's a halogen, 7 minus 2 is 5, so it have 5, so in the midst. So it's valence. If its valence is 5, that last number has to be 5. So I picked that one. This quiz is a little bit difficult because it's kind of hard to look. You could look this up in your book if you like, but you're gonna probably want to know that. But just know this last number has to do with the valence. And all the halogens have 7 minus 2, 5 valence. What is the energy required to remove an electron from an atom? It's called, to remove it, the word remove, I have move, but it's remove, is ionization. Is when you're removing electron, you're making it into a negative ion. That's the ionization energy. What describes how strongly a chemical combined atom draws electrons to itself? So the key with here is the combined atom. It's not an ion, it's a combined atom. And how these atoms can draw electrons to themselves, they call this electronegativity. Electrons are negative, right? So electron negativity means electrons drawing negative to it. But it's a combined atom. So it was the last characteristic. Which are larger, simple cations or the neutral atoms which were formed? So whenever you have a positive number, say you have calcium with +2, it's going to be small. Any positive numbers are small because the electrons are gone. Basically, it's missing 2 electrons, so it's going to be smaller. Just to remember that. So, but if you have calcium with 2, and then you have just a regular calcium, then the positive one's going to be smaller. So which are larger? The neutral. So which are larger? The simple cations with positive or the neutral? The neutral ones are going to be, because any positive is going to be small. A smaller atom in the whole because the electrons are gone. Which of the following elements has the smallest atomic radius? Okay, here we go. These are these little things you have to draw here. So let me put this here so you can see it better. I don't know if I don't have it centered. So, so here we have which of the elements has the smallest atomic radius. So here's what I did. I always put atomic radius means small at the top and large at the bottom, because as you go from the top and more shells, bigger atomic numbers, it's going to be small at the top and large at the bottom. And then you're going to have small on this side. So it's going to go this way and this way, right? And so I find out where these all are. And as I looked here, I found, hope you can see this. Can you see it? Put it here, maybe. See it. So I have magnesium's clear on this side. This is the periodic table. If I took this periodic table, magnesium would be clear over on this side. So magnesium's over this side, and carbon, the C's in the middle, and F's over here. Well, which one would be smaller? Well, as you go from left to right, the one clear over is getting smaller, so the F is going to be the smallest with the radius, because you're going left to right. So always remember small to large to small, and so the F would be, because it would be the smallest. So let's go on to the next one. Which of the following elements has the greatest electronegativity? So I made this. So electronegativity. Let's move over here so you can see it right here. Electro goes opposite from the radius kind, right? So you got large to small to large. And so I look in the table, find where they are on the table, approximately where they're at, right? And so I look here and I find, where are they? Well, aluminum's over on this side, carbon's over to the right a little bit, and oxygen, they're on the same level, C and O. So which one would be larger? Well, because they're going from left to right, small to large, the one clear over towards the largest side would be oxygen. Oxygen. So let's go on to the next one, number 8. Which of the following elements has the most metallic? Metallic, this graph is going to be exactly like the graph we did for the radius. This is the only one. These two graphs, metallic and the radius, are the same. It's only the ionic and the electronegative, all the kind of strange ones that are this one. I call them strange ones. But metallic and size are going to be the same. So here we have, it goes from small to large and then to small. So small to large to small. So I'm going to put these in here. So we find out where barium is and where calcium is, where I put calcium there. I guess I didn't do this one yet. So SR, so let's do it. So let me see where SR is. I have this little tiny, let's see. Calcium. Takes me a while to see these here, so. SR is over here. So calcium, okay. What did I put? Calcium, SR is right below calcium here. All right. And so the SR is right below it. And then BE, where is BE? BE is above it. BE. So we have, in this we'll have BE. Where do I have it? And they're all on number 2. BE, calcium, and strontium, they call it. Okay, these two. So which one, if it was getting, it's going small to large, which of the elements would be largely most metallic? It would be the one that's closer to the large, right here. Be this one. Okay, see how I did that? I just kind of put it there, and which one's on the bottom, because it goes from small to large. So let's go on to number 9. Which of the following ions is the largest? So we go back to the largest. So largest goes from small to large to small, right? Because we're going from small to large. So I always put this here to know which one I'm doing, because one of them's opposite from the other, right? But we're going to find how largest, that means how big their radius is, right? So then I put here, I put oxygens at the top, and then sulfur, and then Te. First of all, I looked, and it looks like they all have negatives, all the same. So they're all going to be the same with their negative. That means they're pretty large because they have extra electrons. But which one is going to be the largest of these 3? So oxygen is the top, and underneath it is sulfur, and then Te, and it goes from small to large. So this one, the Te, is going to be the largest one. Which of the following elements have the lowest ionization? Remember, ionization is going to be from large to small, because it's opposite from the other. So, or opposite from, I should say, how large the atom is. So here we have ionization. So you can get this basically in your book. So left. This is the left side. This is large to small to large. So as you go this way, it's going to get smaller. This way, it's going to get larger. And I plotted them here. We have lithium, nitrogen, and neon. Lithium is way over here. Nitrogen's here. And neon's here. That's where they are in this, over here, here, and here. So I put them there. So now which one's going to be, they say which of the following is going to be the lowest? So which one's going to be the one that's on this side is going to be smaller. That one's going to be larger. So this is going to be the largest. And this one's going to be medium, and that's going to be the smallest. So I circled that one. So now I hope that you got hold of these. And this is for the quizzes. And now we're going to go over the test questions.